Hello everyone, welcome back to our BGP 4.0 hands-on series. In the previous demonstration, we saw one of the powerful concepts on the BGP where we went ahead and did the route filtering. And when we did the route filtering, we did the route filtering onto the incoming direction on the ISP1 router. That means when the ISP1 router was receiving those prefixes, we were selectively allowing some of those prefixes and we were dropping rest of those prefixes. Yes, that approach is good. It did the purpose. We were able to selectively, allow certain prefixes. But if you noticed in that still the router R2 was sending all those prefixes, but ISP1 was the one which was doing the filtering. In our demonstration, it was okay because we only had, few routes that R2 was sending and the ISP1 router was filtering. But imagine a scenario between two enterprise where you have like thousands of routes, where one of the side is really sending, like say 100,000 or maybe, few thousand routes. But on the other hand side, the other side is only interested in, let's say, few routes, maybe, a couple hundred routes out of those, all the 100,000 routes. Now, in that case, even though, yes, we are able to do the filtering, it is serving the purpose, but still a lot of resources are getting wasted on both the sending router as well as the destination router, because the sending router still need to process, all those updates and send it to the neighbor router. And the neighbor router would need to receive all that update and, act on that update and filter all those routes. So, now we are trying to see how we can really optimize this whole thing. And the previous approach is really called as the inbound route filtering. And those were some of the drawbacks, and keeping those drawbacks, in the mind, we are going to take a look at another concept of, prefix-based filtering, which is called as outbound route filtering. So the whole idea between the outbound route filtering is this. Wouldn't it be good that, hey, if the ISP, if let's say the receiving router can tell the sending router, hey, I know that between you and I, we are eBGP neighbor and you are sending me, let's say 100,000 routes. But out of those 100,000 routes, I am only interested in receiving, let's say, those few hundred routes. So if we can somehow, if the receiving router can somehow tell the sending router beforehand, hey, when you send me an update for the prefixes, please only send me the update for certain of these prefixes. So that means when the sending router is advertising, we can, that time we can itself, or that time we can impose that, hey, please do not send me all the unnecessary prefixes, only send me these particular prefixes. And that's where we can go ahead and implement the concept of outbound route filtering. In short, this is sometimes also known as ORF. So we will go ahead and, explore this concept of ORF. There is another thing that you need to keep in mind, that ORF is again, gets exchanged during the initial BGP bring up. So once you go ahead and configure the ORF, let's say you brought up a BGP and later on you go ahead and configure the outbound route filtering, you might have to clear your BGP session and, the neighbor and reset them so they can go ahead and exchange. There are a couple type of capabilities that are in the ORF. There is like send capability, there is a receive capability, and there is something called both capability. So we'll go ahead and take a look and we'll go ahead and do the hands-on demonstration around this particular feature. So for this, again, for this demonstration, we are staying with our smaller topology of those three routers, router R2, ISP1 router, and ISP2 router. So for this demonstration, now we'll go ahead and take a look at that. We know that ISP1 router was also advertising some of the prefixes towards the router R2. Now let's take a look at what are the prefixes that the ISP1 router is advertising towards the router R2. So we can go ahead and take a look at with the help of show IP BGP neighbor command, and the IP address for our neighbor is 172.16.12.2, and we are interested in taking a look at the advertised route. So from ISP1 point of view, ISP1 is advertising these different prefixes towards router R2. So there are total 9 prefixes that this ISP1 router is advertising towards the router R2. We can go ahead and verify the same thing that, okay, hey, what are the prefixes that router R2 is receiving from router ISP1? And router 1 ISP has an IP address 172.16.12.11. So let's go to router R2 and we can go ahead and verify the same thing with the help of show IP BGP command. And here we could see that, okay, hey, these are the prefixes that we are receiving from our ISP1 router. So we have couple prefixes here, 10.0.10/28.16.32.48.64.80, and their next hop is all set as ISP1 router. And then there are a couple more prefixes at the bottom that we can get to see that there are a few more prefixes that we are receiving from the ISP1 router. Now we are getting quite a few number of the prefixes from the ISP router 1, but imagine that if the ISP1 router was literally sending, let's say a few thousands of routes, and we were only interested in, let's say again, very few selective routes. So that's where we can go ahead and use the concept of this outbound route filter instead of doing the filtering on the inbound direction, where the sending router is still sending all those updates, but on the destination, the receiving router is selectively, picking some of the prefixes and, dropping rest of the prefixes. So to avoid that resource wastage and, to be like more useful and, whatever you want to call, okay, to speed up certain things, while doing the advertisement itself, we can go ahead and restrict that, hey, these are the prefixes I'm only interested in receiving pretty much. So in this case, router R2 is the one which is receiving these prefixes from ISP1 router. That means the router R2 is going to be the destination and router ISP1 is the source. So now on the source itself, we will go ahead and apply an outbound prefix list that would dictate, hey, only send me these are the prefixes. And who is going to dictate, hey, send me these prefixes? The receiving router. In our case, the receiving router is R2. So R2 is the one that is going to dictate or mention or, say, okay, hey, these are the prefixes I'm only interested in receiving. So please, when you advertise the routes towards me, please make use of this particular filter, and we'll go ahead and configure that filter again with the help of the IP prefix list. So we'll go ahead and configure an IP prefix list on our router R2, which is the receiving router. And now this receiving router will use this prefix list and will pass this prefix list towards router ISP1. Again, we're going to go ahead and configure this prefix list on router R2 because our receiving router. And we will go ahead and send this prefix list that we are configuring on router R2 to ISP router 1. And ISP router 1 will make use of this prefix list before it will go ahead and send any update towards router R2. So it will take a look at that prefix list and it will act upon that prefix list. So now for that, we need to go ahead and turn on the ORF capability for this particular neighbor. And how do we go ahead and configure that? So let's go to our router ISP1. Router ISP1 is again our source router, and this will be the router that will be receiving that prefix list from R2. R2 is our destination, and R2 is the one which is dictating, hey, before you send me any route, please use this prefix list. So let's go ahead and do one thing. We will go ahead and maybe do the configuration the other way around. Okay, now let's stay with the ISP1. Now, as I said, the ISP1 is the source that ISP1 is going to receive that prefix list. That means we need to go ahead and turn on the ORF capability. And this is the router that will be receiving that prefix list. That means the ORF capability that I need to configure on this router for router R2 will be on the receive mode, because ISP1 router will be receiving the prefix list from router R2. And again, this is configured at per neighbor level. So we'll go ahead and say router, not OSPF, router BGP 100. And the neighbor in this case is 172.16.12.2. And if you take a look at, there are a few things, and one of the things that we are interested in is capability. Advertise capability to peer. So now we are interested in advertising the capability. And if you take a look at in the capability, we have this ORF. Advertise ORF, which is again outbound route filter capability to the peer. So now with the ORF, there are different mode. Again, this will be based on a prefix list. Advertise prefix list ORF capability to this neighbor. So in the prefix list, we can have either send capability to send the ORF to this neighbor. But in our case, router R2 is our destination router, which is going to be receiving these prefixes from ISP1. That means router R2 is going to be the neighbor that is will be sending that prefix list, while ISP1 is going to act upon that. So it is going to be our router which is going to receive that prefix list. So that's what we are saying. Hey, ISP1 router, for this particular neighbor, your capability will be received. We do not have any other option. So let's go ahead and configure that. And now you could see the BGP neighbor went down. The BGP neighbor came up. Now we went ahead and configured the ISP1 side, where we went ahead and configured the ORF capability of receive. That means now ISP1 router is ready to receive ORF from this particular neighbor. Now router R2 is the one that will be sending the ORF capability. So now let's go ahead and configure the same thing. So we'll say router BGP1, and in our case the neighbor is 172.16.12.11, and again the capability would be again ORF. It will be based on prefix list, and again these are the different capabilities, send, receive, and both. ISP1 router is receiving, and we can go ahead and configure send capability. If you want your router, if you think your router needs to do both, you can configure both, depending, sometimes it can send, sometimes it can receive for some of those neighbors, so you can certainly go ahead and configure that. So now we went ahead and configured the ORF capability. Now we have just configured the ORF, so we have turned on the ORF between router R2 and ISP1 router. And at this stage, we can go ahead and take a look at the ORF capability. I'm going to go ahead and show you something pretty quick here. So we can go ahead and say show IP BGP neighbor, and the neighbor in this case is 172.16.12.2. And if you scroll down further in this particular output, okay, here you can take a look at this. Here it says AF dependent capabilities. Another thing that you need to note, and I'm sure if you know BGP, that this ORF is, you can apply at the AFI level or SAFI level, depending on that. And the type for this type of the ORF is the type 128. There are different types like type 1, type 2, type 3. And you could see the send mode is really the receive here. So that means this is the router where the sending mode is received. So this will be the router that is going to be receiving the ORF or the prefix list from the sending router. And you could see the receive mode advertised. So we have went ahead and advertised that particular one. And that's how we know that ORF capability has been exchanged. Now, there is another thing that we need to go ahead and configure. We only went ahead and configure, or we can verify the same thing if you are interested in taking a look at on this side. Show IP BGP neighbor, and this is our neighbor. Let's take a look at. And you could see the send mode is advertised. Again, the receive mode is received. So these are the different things we can go ahead and take a look at. Now, so far we have only turned on the ORF capability between these two routers, but we haven't configured, or R2 haven't really told ISP1 that, okay, hey, I know that you are sending me quite a few prefixes. So if you can see again that our ISP1 is sending quite a few prefixes, but I am only interested, let's say, receiving only one prefix. Imagine that, okay, hey, we are only interested in receiving this particular prefix from ISP1. And we do not want any other prefixes from the ISP1. So for that, we need to go ahead and configure now a prefix list on R2, because this is R2 is the one where the ORF capability is sent. So let's go ahead and configure a prefix list. Again, we would say again IP prefix list, and we can go ahead and give it a name. So we can say in ISP1. and we can go ahead and give any sequence number. So let's say sequence number of 10, and again we are interested in permitting what prefix. So as we said, there are quite a few prefixes that we are receiving from ISP1, but let's say we are only interested in receiving this particular prefix from ISP1. So I can go ahead and copy and paste that. So what we just did here, we went ahead and configured a prefix list. This is the name of the prefix list in ISP1, where we are saying, okay, I'm only interested, I know that ISP1, you are sending me quite a few prefixes. You are advertising quite a few prefixes towards router R2. But I am as a router R2 only interested in receiving this particular prefix. I do not want to do any inbound filtering. I want you as a source router itself, before you send me an update, use this filter and pass the update via this filter. So that means it is going, while advertising itself, it will make use of this prefix list. Now we have only configured this prefix list. Now we need to go ahead and apply this prefix list at our neighbor level. So that means any time when we are receiving an update from this neighbor, which is ISP1, we want that update to be passed by this particular prefix list. So now let's go inside our BGP process 1, and the neighbor in this case is 172.16.12.11, and again prefix list, and the name of the prefix list. The name of the prefix list is in ISP1, and again in what direction? Incoming direction. So what are we saying here? That okay, hey, earlier we went ahead and turned on the ORF capability. With the help of the ORF capability, once they were turned on, router R2 is the one that is going to be sending the prefix list. So this is the prefix list that we went ahead and configured, and in this prefix list we are saying, okay, hey, only allow this particular prefix, and we went ahead and applied this prefix list at this neighbor level. That means when we are receiving an update from this neighbor, please use this prefix list in the incoming direction. And now because the ORF capability was turned on, now let's go ahead and simply clear our BGP session here quickly. Give it a few seconds, and okay, the neighbor went down, the neighbor came up. Now we can go back onto the ISP router 1, because R2 has advertised this prefix list towards the ISP1, because R2 has a mode of send and ISP1 has a mode of receive. So now let's take a look at show IP BGP neighbor, and in this case this is our neighbor. And if you press a question mark here, there are few things here, and one of the options that we have is received here. Let me go ahead and clear my screen. Let's go ahead and rerun the command one more time. Show IP BGP neighbor for this one. So there are a couple options here, and one of the options that we are interested in using, take a look at this receive. What this receives is display information received from a BGP neighbor. So we'll go ahead and make use of the receive. After receive, there are a couple options that we are interested in. And one of the options that we are interested in checking is the prefix filter. Display the prefix list filter. So now let's run this command, prefix list filter, and just simply press enter. And now you could see magically on the ISP1, there is an IP prefix list that is configured where it says, okay, hey, permit only this particular stuff. And again, it is being applied for an address family IPv4 unicast. So now the ISP1 router will use this particular prefix list, particular prefix list anytime when it is trying to advertise any routes towards this particular neighbor. Now, if I go ahead and scroll up and let's see if I have still that output somewhere to show it to you guys. Yep, okay, very good. So now if you can see, these were the routes that ISP1 was advertising towards R2. And you could see it was advertising quite a few number of prefixes. There were a total number of 9 prefixes that this ISP1 router was advertising towards the router R2. Now, after turning on the ORF, we could see that R2 has sent this prefix list filter towards ISP1, and it's being applied for address family IPv4 unicast. Now, take a look at the same command again, show IP BGP neighbor, for this particular neighbor, and let's take a look at what are the routes that ISP1 router is now advertising towards router R2. So now if you take a look at earlier, this ISP1 router was advertising almost 9 prefixes towards the router R2. Now instead of those 9 prefixes, this ISP1 is only advertising one particular prefix. So you can see that outbound route filter ORF is a very powerful concept, and again you could use this and is being utilized because it saves a lot of resources both on the source router as well as destination router. Because with the help of ORF, we really saying, okay, hey, instead of you sending all those 100,000 routes, and I am going to go ahead and do an inbound filtering where I'm going to drop rest of the routes which I'm not interested. I'm telling you my intention early on itself, when you send me an update, please make use of this prefix-based filter and only send me the route which I'm either allowing or denying based on the prefix list that I'm passing. And that is configured with the help of the ORF capability of send, receive, or both. And now we can go back to our router R2 and we can take a look at and see what are the prefixes that we are seeing from our ISP1 router. So we can simply say show IP BGP. And now if you take a look at the only prefix that we are receiving from ISP1 router is that 16/20. So hopefully you got the idea, and this ORF again is called simply as outbound route filtering. And guys, this is again another very powerful concept that is being utilized quite a lot, where instead of you are trying to do an inbound filtering, yes, inbound filtering is good, but you got the idea, that still the source router has to send all those updates and the destination router needs to filter these things. There are still quite a lot of resources that are being utilized in terms of both CPU and memory. But with the help of outbound route filter, you can optimize those resources. Now you are telling your intention early, or hey, so I'm only interested in receiving certain prefixes. So do not send me all the prefixes. Make use of this prefix-based route filter, and that's how you can go ahead and start filtering some of those out. So that'll be all for this lab. I will see you guys in the next. Thank you.